Hi everyone, I welcome you to the presentation of this lecture. This one is a continuation from the one we had previously. This time around, we are going to be looking at a circuit where the voltage is fixed and the load is variable. Okay, so for this circuit, we are given a fixed input voltage and variable load resistance. Our role is to calculate the minimum and the maximum values of the load resistance, sometimes even current. Okay, so the circuit looks as shown below, which is this one. So you have an input voltage VI, which is fixed, but the load is variable there to be varying, and this will result into this current also vary. You can have the maximum as well as the minimum. Same applies for that one. So the maximum and the minimum resistors are given by this formula. So for the maximum resistor, it's given by the voltage for the Zener divided by the minimum current, whereas the minimum load current is given by, you multiply the R, which is this one, multiply by the voltage of the Zener, divide by the difference of the two voltages, the input voltage and the Zener voltage. So this will give you the minimum value of the resistor. So where the minimum current is given by the difference between the current on this resistor and the current going on the Zener. The difference between those, it's going to give us the current which is going on the load, and that is the minimum current. In here, the IR is basically the voltage on the resistor. You divide that by the resistor itself, which is that one there. VR, which is this one, is basically the difference between the two voltages, the input voltage and the voltage on the Zener. That will give us the VR. And lastly, the maximum current is basically the Zener voltage, divide that by the minimum value of the resistor. So these are the basic formulas we'll be using. Let's look at some examples. So the example is saying, for the network shown below, determine the range of RL, IL that will result in VZ being maintained at 10 volts. So VZ has been maintained to be 10 volts. So what would be the variations of the resistor as well as the current? B, determine the maximum wattage of the diode. So in our solution there, we realize that the minimum resistor is basically that from the formula I gave you on the previous slide. If you substitute there, we are going to have 250 ohms as the minimum resistor. The maximum resistor is given by that, the Zener voltage divided by the minimum current. So our role here is to find the minimum current, which is the difference between the current on the resistor and the Zener current. When you find that, you're finding IR as 40 milliamps. Getting this one, substituting into that one, we are getting the minimum current as the difference between IR is this one, which is that one, minus the IZM, which is this one here, 32 milliamps. The difference is that. So IM we have, which is this one here, the Zener voltage we have, which is that one there. When you substitute, we can easily find the maximum range of the resistor. Therefore, our resistor will range from this as our maximum and that one as our minimum. The currents, the minimum current automatically is this one here. We just need to find the maximum current. So the maximum current is given by that. We have all these parameters. When you substitute, we are getting that as our maximum current. And then the B part is saying we calculate the maximum wattage of the diode, which is basically the Zener voltage times the current on the Zener. These we have them in the circuit. When you substitute, we are having that. Therefore, the range, because the question was saying we find the range of the current as well as the load. So current will range from 0.008 amps as the minimum, and then it's giving us 0.04 amps as the maximum. Whereas the resistor is going to range from 250 ohms to 1250 ohms as the maximum. So this marks the end of this presentation. Thanks for